Hello. Now we want to solve a question on WACC and Bosco. It's a very good question. I'm going to solve two good questions. I'm going to solve another one after this video, which addresses different types of capital again. This one, I'd love it as well because this one question has three different forms of capital. And the first one, as you can see there, is ordinary shares. We have convertible debt and we have bank loan. But I want us to start practicing how to use those 5 steps approach to WACC, which I taught you in my previous video. So remember, to calculate WACC, we're going to use 5 steps. Just to simplify it and make it so easy for you. I need you to be confident. Some students, when they see WACC, they are scared, they are worried. I don't want you to get rattled. When you see WACC, I want you to be confident. So think about it this way. Step 1. Remember, which is identify the forms of capital in the question. And what can you see? You can see forms. This is our step 1. The number 1 there says number of ordinary shares, so which means there's equity. So we have equity. We have convertible debt, not just debt, but the convertible debt. And we also have bank loan. So we have done step 1. So this is our step 1. So we have passed. What is step 2? Step 2 says we need to get a proportion. Yeah. So step 2, we need to get the proportion of each capital. So we'll start, we have 3 here, 1, 2, 3, yeah? So the first one is equity, so we need to get the proportion of equity that we have in this question. So for us to be able to do that, first of all, we need to get the value of each debt that we have. We need to get the value of each of them. And when we add the value of each of them, we'll add them together to get the total volume that we have, because the proportion is the volume of one debt divided by the total volume that we have. So let's start with equity. What is the volume of equity that we have? So value of equity, we're given how many shares? They said this is 20 million shares. And they give us the price of the shares. Let's look at the information we've been given. Bosco wishes to calculate this weighted average cost of capital. The following information relates to the company at the current time. Number of ordinary shares, book value was given, book value of bar was given, market price of ordinary shares was given, 5.5 per share. So the volume or the value of equity is 5.5, which is the price of one share, multiplied by the total numbers of shares that we have, which is 20 million. And that will give us 5.5 times 20, and that gives 110. And my calculator, I'm sure if you press it as well, you should have the same thing. So that's $110 million. So that is the volume of equity. What about convertible debt? Let's get the volume of convertible debt as well, because we can't get a proportion without knowing the volume of each of them. So for convertible debt, do we have the price of convertible debt? Let's look at that. It said Bosco expect share price. So we have, after the market price of ordinary shares here, which is 5.5, we have that. Then we have the market value of convertible debt. It was given at 107.11 per 100 bond. Remember, I told you that one bond is $100 per value or face value. but that is par value. That is called face value. That is not the price of the bond. Now, we've been given the price of the bond at 107.11, but the question is, how many bonds do we have? So we can get the total volume of bond that we have. The book value of the convertible bond was given at 29 million. Yeah, so 29 million is the book value of the bond, and that means that the face value of the bond is 29 million. Right? But remember, 29 million is face value, which means, let me work it for you. So face value or par value is $29 million. Yeah. So, and that means that, and we know that one bond has a face value of $100. So how many bonds do we have if the total face value is 29 million? It means you need to cross multiply like this. Yeah, so that's 1 times 29 million divided by $100 million. And that gives us how many bonds? That's 29 million divided by 100, and that gives 290,000 bonds. So we have 290,000 bonds. So this is the number of bonds that we have. So if one bond is going for 107.11 and we have 290,000 bonds, what is the market value of our bond? That will give us times 107.11, and that gives us 31.06 million. So the market value of the bond is 31.06 million. Remember, the type of WACC that we're calculating here, which is the best form of WACC, is market value based WACC. Yeah, the question can ask you to also calculate a book value based WACC, but I will go into that later. That is easier. In that case, you don't need to calculate all this market value. You just use the book value, which is, instead of calculating 110 for equity now, you just use the book value of equity, yeah, which is book 20 million multiplied by the nominal value of the share. You will not use 5.5. You're going to use nominal value of the share, which question will give you. Or they give you the financial statement and they give you the equity or share capital. That is the book value. Book value is the value on the financial statement. And for convertible bond, the book value is 29 million. But we don't want to use book value because we're going to calculate the weighted average cost of capital on a market value basis, because that is a better form of WACC. Why is it a better form of WACC? Because it reflects the market reality of the company. That's even a typical example you can be asked. Why market value WACC is better than the book value WACC? So going back to what we're doing, so we've gotten the volume of equity now, we've gotten volume of debt. Now we still need, there's a third one, bank loan. So we need the volume of bank loan as well. So for bank loan, please note that there is no market value for bank loan. So if question even asks you what assumptions you've made in any question that has to do with bank loan, always remember to say that you have assumed that the book value of bank loan is the same as the market value. So in this question now, the bank loan has been given at, let's see, do we have any figure for bank loan? Ordinary shares. Yeah, bank loan has been given here. You can see book value of bank loan is 2 million. So we'll stick it there like that as 2 million. So which means the total capital that we have raised is equals to 110 from equity, 31.06 from convertible debt, and 2 million from bank loan. And if we add all of that together, 110 plus 31.06 plus 2, that gives a total of 143.06. So that's the total capital that this company is using. Now, what is the proportion? Proportion of each of, remember step 2 is to get the proportion, which is what we are waiting for, yeah? Proportion. Now, for equity, the proportion of equity in this 143. So for equity, so PE, which is proportion of equity, will be equals to the volume of equity, which is 110, divided by the total, 143.06 times 100%. And that gives you, let's see, 110 divided by 143.06, and that gives you 76.9%. Proportion of convertible debt, that's 31.06. Remember, convertible debt is this, 31.06 divided by 143.06 times 100 as well percent. So that's 31.06 divided by 143.06 equals to that 21.7%. And lastly, proportion of bank loan is 2 over 143.06 times 100. Now equals to 2 divided by 143.06. That gives us 1.4%. And the way to check what you have done is to add everything together. It should give you 100%. So if I add 1.4, so 1.4 plus 21.7 plus 76.9, you can see this is exactly 100%, because all the capital proportion must give you 100%. So it's a very good way to know whether what you have done is right or wrong. Now let's plug it here in our table. Equity at 76.9, so this is 76.9%. Then we have 21.7%. Yeah, I think the last one 1.4%. So we've done with step 2. Step 3 is to get the cost of capital for each of them. So we need to get the cost. Yeah, we need to get the cost. Let me use writing cost so you don't get confused with K. I need you to be very comfortable with this topic. It's very interesting and nice topic. Cost. Yeah. So we need to get the cost for each of them. Let's do with cost of equity first, or step 3. Now I want to get the cost of capital for each of the type of capital that we have identified. And we're going to start with equity. Now look at this question. Remember, when we did cost of equity, there are 2 models for determining cost of equity. Yeah, we said there's a dividend model and there is CAPM, right? And dividend model is that you have a constant growth dividend or constant dividend when dividend is not changing. And you use different formula for that. And CAPM is when you use beta in what you have to calculate. But let's look at this question. Which model do you think will be applicable here? Do we have dividend information? We do have dividend information, but we have beta information, and that automatically shows you that we'll be using CAPM for this kind of equation. So what is CAPM? CAPM say cost of equity is risk-free rate plus beta into bracket return on market minus risk-free rate. And this is also called market premium, remember. So sometimes if you don't have each of that and you have market premium, that means everything in that bracket has been given to you. So take note, those are the little 2 traps that the examiners want to put you in. So risk-free rate is given at 4.7%. Do we have beta? We are given beta as well. Beta is 1.2. Market return you can see in this question we don't have market return, but we have been given the equity risk premium. And like I said, risk premium is the same thing as RM minus RF, because we are saying what is the excess, what is the additional benefit that an investor is collecting, that is getting, because the investor has put money in something that is riskier than a risk-free investment. So because you have invested in market is riskier than a risk-free investment, and because of that, you are getting higher return from market than risk-free. So the excess, the additional return you are getting is the premium, and that is why is the whole of this bracket, that is the premium. And that premium has been given to be 6.5%. So knowing this, if I ask you what is the market return, which is a typical question you can get in a multiple choice, the market return has to be 6.5 plus 4.7, because mean that market is given 6.5 plus 4.7. So market is given 11.2. So if market is given 11.2 and the risk-free investment is given 4.7, it means that you have premium of 6.5. It means you have excess return of 6.5 because you have decided to take more risk. Remember, the higher the risk, the higher the reward. Yeah, and if you do that, your cost of equity becomes what? Calculate all of that together. That's 1.2 times 6.5 plus 4.7, and you get 12.5% as the cost of equity. So now we have the cost of equity. The next one, which is the second one, is the cost of convertible bond, which you need to pay attention. Convertible debt. This is extremely important. I know I've taught you the concept of IRR before, which we're still going to use here, but there's something that we need to do here that is different from the last lecture, which is where I dealt with redeemable debt, right? This is a bit different, though it's still IRR. Cost of debt for convertible debt is still IRR. However, you calculate IRR after, please take note, after test of conversion. Because your test of conversion will tell you whether an investor will convert or not. Remember, what is convertible debt? Convertible debt is just your normal debt, but the only difference is that it has an option. The holder or whoever has given that money, whoever has given that loan, has an option to exercise. And what is that option? That option is the right to convert the debt to equity. Yeah, you can decide to convert that money that you have given out to equity. So you can decide to tell the company to say, don't worry, don't pay me back. You don't have to pay me back. Give me shares of your company so that I can become a shareholder. So an investor has that right to do that. So it depends on him whether he wants to exercise the option or not. So your test of conversion will check whether a rational thinking, a reasonable investor will exercise the option or not. And if I ask you, what will make you think someone will exercise? It will exercise if the share value is greater than the debt value, the debt repayment. It's as simple as that. That's your test of conversion. That's what you want to check. If the share value is greater than the debt value, yeah, it's going to exercise. It's going to convert. So which means at the end of the tenure of the debt, it's not going to be getting its cash back as redemption, but rather it's going to be converting to shares. And that means you're going to be working with a conversion value. And you will see how we're going to apply that in this question. Right. So now what we want to calculate is IRR. But remember, before we calculate IRR, let's quickly test for conversion. So let's quickly do our test of conversion, so that we know at the end of tenure of this loan, would there be a conversion? We need to quickly do that. So let's do test of conversion. What is the tenor of this? Let's find out. So if you look at this, BOSCO expects share prices to rise in the future at an average of 6% per year. The convertible debt can be redeemed at par in 8 years. So remember, if you have a convertible bond, there are two options. Option 1 is redemption, which means collect your money back, repayment. Redemption, that is cash repayment. And option 2 is conversion to shares. Those are the two options. So what we want to do is, will the investor do this one or will he do this one? Which one do you think an investor will do? So which means we need to calculate what is the redemption value, the cash repayment. After 8 years, they said it is redeemed at par. So there's nothing you can do. It's going to be redeemed at par. And par is 100. So after 8 years, it will get $100 for each bond. That is option 1. But what is the value of option 2? For each bond, how much shares will it get? The question says that, or you can convert in 6 years' time into 15 shares. So the option 1 is wait for the 8 years' time of the bond and collect $100 for each bond. Or you might not even have to wait till 8 years. In 6 years' time, you can decide to convert each bond to 15 shares. So the question is, what is the value of the 15 shares? That's what we need to know. Because the value of 15 shares, that is our conversion value here. What is the value of 15 shares in 6 years' time? Today, each share is worth $5.5. Today, each share is worth $5.5. That is what we have been told here. You can see it here. This guy is worth 5.5. But we also know that these shares will increase at 6% per year. So which means the share price in 6 years' time will not be 5.5, but will have increased at 6% every year. So which means that if you remember this formula, future value equals to present value into bracket 1 plus r raised to power n. We can use this formula to get the future value of that share by growing the share at 6% every year. So the future value price of the share will equal to present value, which is the share price as at today, 5.5. Then we'll grow this present value at 6% for 6 years. N is 6, so 6 years. So when we do that, 1.06 raised to power 6. That gives 1.41, so this equals to 5.5 multiplied by 1.42 times 5.5. So we have a share price that is given 7.8. That equals to $7.8. So per share in 6 years' time. So in 6 years' time, the share price will be 7.8 per share. And for each bond, you will get 15 shares. So if you're going to get 15 shares, so value of one bond, remember, because this one bond can be converted into 15 shares. And that 15 shares will be worth 7.8 multiplied by 15. And that will give us $117 for each bond. So the conversion value in 6 years of each bond is what? Is $117. So we'll come back here and we'll put 117 here. So my question, if you are an investor, will you go for option 1 or you go for option 2? And I know that definitely this is your choice. So which means the conversion is option 2 that the investor will take. Now we can now go to plot our cash flows. Remember, to calculate IRR, which is what we need for convertible bond, we need to plot cash flows. But we need to test for conversion so we can pick the right cash flows. Now, if you remember what I taught you just the last video, how to calculate IRR, always plot your cash flows in a constant way so that every time you are interested in calculating net present value, you are used to your style and you don't have to struggle, right? The formula for IRR, if you remember, is equals to the lower rate plus open bracket the NL into NL minus NH multiplied by H minus L, right? So we need net present value using 2 discounting rates. So I always say use 5% rate and 10% rate just to be consistent and make life easy. You can choose 2 different rates. You will be scored 100% once your calculation is correct. You are not mandated to use a particular rate. By the time we do net investment appraisal, I will teach you how to be more accurate with rate choice, but I'm just teaching you for knowledge's sake, especially if you want to write CFA and it makes life easy for you. Yeah. And also maybe your advanced paper. But for this paper, you can choose any rate that you like and you will score your full marks. Right. So now let's plot our cash flows. We always plot with year. We'll put the cash flows, put the discount factor, and we'll get the PV. Right. So now we're gonna have, let me make it so that I can put everything in one table. Let me make it a bit so that I want to do it in one table. So let's do year. So we have year 0, year 1. Because it's constant cash flow for how many years? For 6 years now, because we say it's conversion, so we're not going to use 8 years. Take note. If it was redemption, it's going to be over 8 years. But because we have seen that the conversion value is more than the redemption value. Remember, this is 8 years time. Yeah, and this is 6 years time. So since we've gone for this option, our cash will be plotted over 6 years. Please take note. So 1 to 6 years and 6 years end of the life. Right. So we need to plot the cash flow. Yeah. For year 0, what's the price? The market price of the bond is 1.07. Yeah, is 1.07 here. So we're going to buy the bond for is cash outflow, so 107.11. Then 1 to 6, what's the coupon rate on the bond? The coupon rate on the bond is 7%, which is given, right? However, tax is 30%. So which means you get, I told you yesterday in my previous video that coupon cash flow is rate times 100 all the time. So this bond will pay 7 all the time. But when you make income of 7, taxman is going to ask you to pay tax. So the net cash flow that comes to you is 1 minus tax rate, 1 minus T. So that's 7 multiplied by 1 minus 30%. So eventually you're going to get 4.9 dollar because you have paid 30% out of 7. So 7 times 70%. So you're going to get 4.9 every year. Yeah, so this is 4.9. And at the end of year 6, you're going to get 117, which is your conversion value. Remember? Where is it? Yeah, this guy. Not 100, but this time 117, because it's conversion you are going for, because it's better value for you. So this will be 117. Now we need to get a discount factor that we will use. I told you for current cash flow that is happening today, discount factor will always be 1. This is at 5%. Remember, we're going to do 2 different rates. Yeah. Then for 1 to 6, that is annuity cash flows, because remember, when you have the same cash flow happening more than once, 1 year, 2 years, 3 years, once is more than 1 year, it's happening more than once, it becomes annuity. And to calculate the present value of an annuity, you can use the annuity table. You don't have to use discount factor and start discounting each cash flow every year. You can discount that one cash flow, but instead of several discount factors, use one annuity factor. So we're going to use 5%. Under this 5% column, then we'll come to 6 years. And if you do that, you see that the rate to use is 5.076. That's the annuity factor, 5.076. However, for this 117, that is a single cash flow. So it's not an annuity. So here we're going to use a present value table. You can see I've switched to present value table. And I'll go to 6 years under 5%. So if I go to 6 years under 5%, that is 0.746. Yeah, and we can get the present value for this one. So this remains minus 107.11. Then I do 4.9 multiplied by 5.076, and that's 24.87. And the last one is 117 multiplied by 0.746, and that's 87.28. And if we add everything together, we get the NPV, net present value, at 5%. Let's see what that is. Plus 24.87 minus 107.11. And that gives 5.04. So that is the NPV at 5%. But we want to calculate IRR, so we need another NPV at a different rate. So this time around, let's go for 10%, as we've always been doing. So we need to get a discount factor at 10% so that we can get another NPV. So we'll get another PV here. Right. So remember, discount factor for current cash flow will remain 1, regardless of the rate. But now we need to get annuity factor at 10% for 6 years. And that will be 4.355. This one on top here. Yeah. 4.355. 4.355. Then we'll go to PV. 10% 6 years. That's a 0.564. 0.564. Yes, so now let's get a PV. This remains minus 107.11. Then we'll have cash flow of 4.9 multiplied by 4.355 annuity factor, and that gives 21.34. Then we have 117 cash flow multiplied by present value factor of 0.564, and that gives 65. 0.99. And when we add everything together, we'll have NPV, our second NPV, which is NPV, and call it NPVH, I rate, yeah. And that's 65.99 plus 21.34 minus 107.11. And that gives minus 19.78. Now, since we have this, we can just calculate our IRR straight away. Remember, IRR is L plus NL over NL minus NH into bracket H minus L. Put everything into brackets. So our L here is 5%, as has always been. NL is 5.04 into 5.04 minus 19.78 divided by 10% minus 5%. Right, this is 10 minus 5%, right? Right, so I always like you to deal with this part so that you don't get confused. So I bring it down, 5% plus. So if you first of all add 5.04 plus 19.78. Remember, minus turns to positive. So I'm going to say 5.04 divided by that. So 5.04 divided by the addition. So that gives 0.20 multiplied by 5%. So hope it's making sense. So that equals to 5% plus 1.02%. And that equals to 6.02%. And that is IRR. So which is our cost of convertible debt. Usually in a question like this part will get the highest form of mark in allocation because it requires a lot of calculations. So 6.02%, let's go to our table. Yeah, so equity will go 12.5. Where do we do that? Cost of equity, we didn't plug it. Yeah, here, 12.5% for equity. And cost of debt will go 6.02%. Then bank loan, which is the easiest one. For bank loan, we said the way to calculate cost of debt for bank loan is just to say interest rate into bracket 1 minus tax rate. Do we have the interest rate for the bank? So if you look at the bank, 8% we're given. Bank loan is at 8%, as you can see it. So this equals to 8%. Sometimes they might not give you. If they don't give you, you can take an assumption, use 5%, use 10%. Yeah, but make sure you apply the tax rate to adjust it. Yeah, and that equals to 5.6%. So that is cost of bank loan. I'm going to put it on our table. Bank loan is 5.6%. And what's our step 4? Step 4 is to just multiply step 2 and step 3 together. Yeah, so if we multiply step 2 times step 3, that means 76.9% multiplied by 12.5. So that gives 9.61. And do 0.217 times 6.02, 1.3%, and 1.4 times this as well. I have 0.08%. And what is WACC, which is step 5? The last step. Easy. The final step. The final step is just to add all of this together, and that becomes your answer for step 5. Yeah. So you add all of this together, plus 1.3 plus 9.61. That gives 10.9. And that is your final answer here. Your WACC is 10.9%. Easy. So the WACC for BURSE is this 10.9%, which you can approximate to 11 because 10.99 is what I have here. All right. If you add everything together, it gives you 10.99, so which is like 11%. But look at how simple we have done it. Quite simplified. Remember, step 1, identify all the forms of capital you have. Calculate their proportions. Calculate their cost of capital. Multiply proportion by the cost of capital, then add together. That is your WACC. It's as simple as that. That is the step that we have followed in each of these. And that is how we got our final WACC to be equals to 11%. Very easy. And take note of the conversions that we have to do for convertible bonds. Yeah, because it's quite important. You don't miss it at that point. If you don't get it right there, you might actually struggle. And that is it for WACC. I'm going to do another question on WACC again. And that will be AMH, this question. Yes, I love this question as well. It's a very nice one. It has different types of capital as well. I can see ordinary shares are here. I can see preference shares are here. You can see redeemable bonds are here. And you can see bank loan here. So, excuse me, this one actually has 4 types of capital, 4 forms of capital that I will deal with. And I can see, looks like we're going to be using dividend growth model here because there's no CAPM, no better information, but I can see a lot of dividend information. So this is a very nice question to also refresh your memory on cost of capital. Yeah. So once I'll do this AMH in my next video, then we'll move into something else in cost of capital, where we'll be dealing with asset and beta gearing and all of that. Yeah, but please, if you have any question, remember, put comments, like the video, share with your friends, and let's keep the conversation going. Until speak again.